Our next section to talk about here is going to be defining these intersectional strata. And once we've done that, to look at descriptive statistics at the stratum level to better understand them. So in this intersectional MAIHDA approach, these kind of complex social identities formed from multiple characteristics are essentially what is done is that all possible combinations of the variables in question are considered. And so the variables were sex, race, education, income, and age. And you saw earlier that they're all categorical. Clearly, income and age are both continuous variables, which have been categorized for this purpose. And so that's something to bear in mind, and perhaps a limitation of this approach at the moment that you're working with categories. There are things which can be done to address that, but we won't talk about them here. So with these, because sex has two categories, race 3, education 4, income 4, and age 4, collectively that leads to 384 theoretical combinations or strata. However, in our data set, despite being 33,000 observations, 2 of those are not observed, and I've listed those here. So the first of these is female, black, high school dropout, high income, age 18 to 29. And so the reason that we don't observe anyone there is because it's an unusual combination of characteristics. So they are black, high school dropouts, and young. So it's only black and high school dropout and young, yet they have a high income. Okay, so you wouldn't really predict people to have a high income if they're from these marginalized groups and they're young. You know, incomes tend to raise as you grow older. So that's not surprising. And the second one is just the same, but young to middle age instead. So they've got no respondents. So we've only got 382 observed strata. So the innovation with the multi-level approach here is that we treat individuals not as nested within, say, geographic areas with administrative boundaries, and not individuals within organizations. Those are typical applications of multi-level models. We're going to treat individuals as nested within these strata, which are defined from their characteristics. Now, in doing that, we have these kind of complex social identities at level 2, and the way they're defined by sex, race, education, income, and age. By doing that, we're elevating conceptually those variables from level 1 characteristics of the individual to level 2 characteristics of these complex social multifaceted identities. So 2 things to discuss here. First, if I get my pens out, we've got a new variable, which I've called stratum, which is a unique identifier for the 382 strata. Now, my first few individuals differed, okay, in terms of their characteristics, okay. These variables were varying across the individuals, and so they relate to 3 different strata, okay. But we'll find multiple instances of male, Hispanic, high school, low, 18 to 29 in there if we resort the data by stratum, which you might want to do. So we've got that, and now look at the explanatory variables. These were previously x1i, x2i, x3i, x4i, x5i, but now we write them as x1j through to x5j. And this is because these are kind of characteristics now, conceptually, of the stratum, which is the level 2 variable. Put differently, if you take a given stratum, these characteristics are constant across all individuals within them. All individuals have this exactly the same set of characteristics as their stratum. So this links nicely back to intersectionality, where there's an encouragement not to kind of view these identities, these gender and ethnic identities, as personal, private characteristics. Why? Because there's so much so many kind of broader social issues around them, not just sexism, racism, classism, but kind of privilege and power and advantage and disadvantage more generally, that these are kind of societal concerns. And if they're treated as kind of private, personal characteristics, then it kind of risks blaming the victim. It's therefore they have a poor outcome because of their characteristics, when really it's how society views and interacts people with different identities, which is the kind of the concerns which intersectionality is driving at addressing. So let's clear those pictures and march on. Having defined our 382 strata, let's do some appropriate descriptive statistics. So the first thing we want to know is, how many people are in each of these strata. And so here's a histogram of stratum size, and it's a very uneven distribution. We say there's a lot of imbalance in the multi-level data structure. We've got lots of strata which which have very few people. Indeed, we see that the minimum stratum size is 1, and we actually have 4 strata which have just 1 person in each. So if we look at those, clearly we're learning about a particular individual in that stratum. We're not really learning much about that stratum per se, and that's something which is going to come back lots here in this course, and how intersectional MAIHDA addresses that. So the mean stratum size is 86 individuals, but it's obviously another skewed distribution. So the median is less, just 54 individuals in the typical stratum. Now, in absence of oversampling of those hard to reach groups, Hispanics, Blacks, that we saw earlier, we would have had even more imbalance typically. Right, let's now look at the actual data. So on the y-axis, I have BMI, and on the x-axis, I have my 382 stratum. So the gray dots, and there's 33,000 of them, are the individuals, and the black dots are the observed stratum mean BMI. So every column of gray dots is a set of individuals who belong to the same stratum. They are identical in their sex, race, ethnicity, income, and age. Okay, but then as we move across the stratum, we are varying those characteristics. So what you see immediately is that whilst there is this kind of interesting stratum to stratum variability, which our multi-level models are going to study, okay, it is dwarfed by the much greater variation within any given stratum across the individuals. And that's a key point here, which the intersectional MAIHDA approach is going to get. So that gray variation is individual heterogeneity. And so remember, MAIHDA is multi-level analysis of individual heterogeneity, the gray, and discriminatory accuracy. We're interested in how the ability for the model, and here it's going to be the stratum membership, to discriminate between individuals, to be predictive of individual BMI. So we're going to have limited predictive power, clearly, of stratum membership here. Nevertheless, it's still going to be interesting to study these differences, but it's important to bear in mind the substantial within stratum variability. One kind of other thing to note here is that there's a kind of what appears to be a noticeable hike up in an elevation of mean BMI as we shift just about here. And if you look at the data, you can see the way the stratum IDs are defined. When we get the elevation, this is Black woman having a noticeable elevation versus other groups here versus white women. So that's what we can kind of see visually, which is already hinting at a two-way interaction, which is going to come back in spades later on. So here I've taken the black dots, the observed stratum means in the previous slide, and I've kept those, and I've zoomed in, and I've got rid of all these 33,000 individuals. And this is just so we can zoom in a bit and see the variation in the observed stratum means. And you can see that we've got lots of observed, so lots of strata whose observed means are kind of above the BMI 30 obese line. Okay, so the mean BMI of the individuals in these different strata here, whatever they are, actually quite a few of those are Black women with various other characteristics, is actually in the obese line. But then there are kind of ones and twos down here, which are in the normal weight range where 25 to 30 is overweight. So what we're seeing here is a lot more variation in the means across these categories or these strata than we saw, for example, earlier. Okay, but that, in terms of the characteristics themselves, where the means were all within the 25 to 30 range. But that's expected because these are big subpopulations, even in the 18 to 29, where 27%, oh, no, hang on, sorry, we've got to look at this one, sorry, where 14% are in the youngest category. That's still kind of 3,000-4,000 individuals. Whereas as we shift on to these strata, we know that we've got many which are much smaller than that. Indeed, 4 only have 1 person. So these strata means, some of these are very small and are very erratic and imprecise and not trustworthy, not reliable as a reason for that. So that's going to be an important feature of the data that we're going to build into the analysis and do something about the noise. And just to drive this point really home, we're going to look at this next slide where I've kept the y-axis the same. So I'm plotting observed stratum mean BMI for my 382 strata, but I changed the axis, the x-axis to stratum size, the number of individuals or respondents per strata. And here what you can see is, well, apparently, according to Adobe Acrobat, we can see a graph showing a number of particles, description automatically generated. So these yellow boxes are AI in action, and it's not very good. I hope my explanation of this plot is going to be better than Adobe Acrobat. I've still got a job for now, so that's good. Essentially, we've got a funnel plot here, and as you can see, the dots kind of funnel in to the mean as we pump up stratum size. And that's the classic plot we see, which shows that means based on smaller samples are more erratic. So these dots up here, these strata with, wow, really high mean BMI, they've got 1s and 2s and 3 participants in, and they're not trustworthy at all. And so a league table of strata in the tails of them are going to be dominated with minute strata. And that really runs the risks of poor decisions being made off such a league table. So let's even just look at that now, just to highlight that. So here is a stratum level data set where I've sorted where the top 5 are the 5, get my pens out, are the 5 strata with the highest observed mean BMI. So look at this, 35, 34, 33, they're all above 30. Whereas the bottom 5 down here, the bottom of the league table, we miss out everyone in between, they've got mean BMIs all in the normal weight range. But the crucial thing here is the stratum size, because in the top 5, look, we've got this one with only 3 respondents, this one with only 2, this one with 3, this one with 1. Only 1 in the top 5 has got a decent sample size, so we might actually think that the observed stratum mean is reliable. The other 4 are clearly unreliable. Okay, and that's the real danger of just doing a straight descriptive analysis here. We need a kind of a model-based approach, which is going to do something about this and get a more optimal set of predictions than the simple observed stratum means.